Hi mathematicians, this is Mr. Almeida. I hope you're doing well. In today's video, we are going to talk about what it means to divide decimals. Okay, before we start any of this, I do want to let you know on a fact that has always been true, but it's really going to make itself clear in dividing decimals. So this fact is when you're dividing any expressions, make sure that the divisor is a whole number, okay? You always have to make sure that the divisor is a whole number. So say, for example, you are dividing, let me do this off to the side. Say, for example, you're dividing 25 by 5. You're dividing by a whole number, so go ahead and divide as you normally would using the standard division algorithm, okay? But in the case that you do not have a divisor that is a whole number, you're going to make it a whole number by making an equivalent fraction. In this case, an equivalent complex fraction, okay? All right, so here are the steps to divide decimals. In the case of dividing decimals, multiply both the numerator and denominator of your complex fraction. A complex fraction is simply the division of two fractions, and decimals are fractions, okay, by a power of 10. That's necessary to make the denominator a whole number. Let me explain what I mean when I say this. So we're dividing numbers. Are we dividing by a whole number here? Yes, so we can just divide as normal. However, in this case, we are not dividing by a whole number. We're dividing by 5/10. So we're going to have to multiply this denominator, in this case 5/10, by some power of 10 to make it a whole number. And because we don't want to change what this complex fraction is, we're going to, whatever we multiply the denominator by, we're going to multiply the numerator by, because we want to make an equivalent complex fraction, okay? So whatever we have to multiply the denominator by to make it a whole number, we'll multiply the numerator by that same power of 10, okay? Then, once we've done that, we'll get an equivalent complex fraction, and then we just divide as normal. And we keep the decimal point of the quotient, the answer we get, exactly where it appears down here in the dividend, okay? And that's the number that's being divided. One more thing to keep in mind, if as you're dividing, you end up with a remainder that is not 0 to the right of the decimal point, you're going to annex zeros to the right of the dividend. And I will do all of these steps in the colors. So I'll do the multiplying numerator and denominator by the power of 10 in blue, and I will annex zeros in red, okay? Remember that annexing zeros to the right of non-zero decimal digits is the result of multiplying both the numerator and the denominator by the power of 10 that matches or corresponds to the number of zeros that you want to annex, okay? And then lastly, if in a number you don't see the decimal point, annex it to the right of all the digits. So for example, if you see this number 16 and you don't see a decimal point, the decimal point is annexed to the right of all the digits, okay? And then here you can annex a whole bunch of zeros if you'd like, okay? And that will not change the value of this number because it is still 6 ones and 1 10. All right. Okay, so let's now put into action what we've just discussed. Just to recap before we get into the process, if we're dividing, we have to divide by a whole number. If we're dividing by a whole number, great. We divide as normal. And we put the decimal point exactly where it is in the dividend, in the quotient. And if we're dividing by is not a whole number, then we're going to multiply it by a power of 10 to make it a whole number. And then we'll do the same thing to the numerator. And then we divide as normal. And if we have to annex any zeros to the right of the decimal point, we can do that. And we divide as normal. All right, here we go. All right, so in this first example, we're dividing 125 tenths, hundredths, thousandths, 10,000, hundred thousandths by 5. Are we dividing by a whole number? Yes, so we can divide as normal, okay? So we'll write the dividend, the number that's being divided on the inside, and the number that is dividing on the outside. Then we will copy in the quotient blanks, and the decimal point will stay exactly where it is. We just write it right above where it is in the dividend. We'll put it in the quotient. All right, here we go. How many 5s are there in 0? 0. How many 5s are there in 0? 0. How many 5s are there in 0? 0. How many 5s are there in 1? 0. How many 5s are there in 12? 2. So 2 times 5 is 10. We write the 10 underneath. The last digit of 10 will go underneath this 2 that you put right there, underneath right there. And then we'll do the subtraction. 2 minus 0 is 2. 1 minus 1 is 0, and we're all set. Okay, the remainder of 2 is less than what we're dividing by 5, so we can pull down the next digit, making this number 25. Now we ask, how many 5s are there in 25? And there are 5. So 5 times 5 is 25. 25 minus 25 is 0. Did we get a remainder of 0 to the right of the decimal point? Yes. Are there any other digits to pull down that are not zeros? No, so we're good. We have our quotient of 0.00025 or 25. Let's see what this is. Tenths, hundredths, thousandths, 10,000ths, 100,000ths. 25 100,000ths. Okay? So that's how we divide. If your divisor is a whole number, just divide as normal, okay? Make sure your decimal point gets copied right where it is in the dividend in the quotient. All right, here we go. Next one. Our next division expression is 125 hundredths divided by 5 tenths. Are we dividing by a whole number? No. So we're going to rewrite this as a complex fraction. That is the division of two fractions. Okay? And then we're going to ask ourselves, what do I have to multiply the denominator by to make this a whole number? Well, we're going to multiply it by the power of 10 that is necessary to make the denominator a whole number. So what do I have to multiply the denominator by? What power of 10? Well, let's see how many decimal digits there are. That are digits to the right of the decimal point. I have 10 to the first power, or simply 10 because there's one decimal digit. Because I want to make an equivalent complex fraction, I'll multiply the numerator and the denominator by the same number, which is 10. Okay, now when I multiply 5 tenths by 10, each digit gets one place bigger. So right now that 5 is going to go one place bigger than it is up here. One place bigger to the left is making it 5 ones, okay? So that's going to be 5 in the denominator. And then each digit's also going to get one place bigger in the numerator. So that 1 is going to go to the left of the 1. The 2 is going to go above the 1, then the decimal point, and then the 5 is going to go to the right of that. And there are no more digits to the right of this 5. So it is 12.5. So when I multiply 1 and 25 hundredths by 10, it becomes 12 and 5 tenths. Each digit gets one place bigger. The decimal point doesn't move. It's the digits that shift over a certain number of places. All right, now I have 12.5 divided by 5. I am going to write what I'm dividing in the box. So that is going to be 12.5. And on the outside, I'm going to write the 5. And I'm going to put my blanks above the digits of the dividend in the quotient and copy my decimal point right above where it is in the dividend. And now let's divide as normal. Now we can treat this as whole numbers and ignore the decimal point because it's already in its place in the quotient. How many 5s are there in 1? 0. How many 5s are there in 12? 2. 2 times 5 is 10. That last digit is going to be written underneath this 2 that we wrote right there. So it'll be 10. 12 minus 10 is 2. Pull down the 5. Now we ask how many 5s are there in 25? 5. 5 times 25 is 25. 25 minus 25 is 0. Did we get a remainder of 0 to the right of the decimal point? Yes. So what is our quotient? So that means we are done. So our quotient is 2 5/10. Okay? Now we are going to divide 5/10 by 1 25/100. We're dividing by a whole number? No. So therefore, we're going to copy this complex fraction. And we're going to ask, what power of 10 do I have to multiply 1 25/100 by to make a whole number? Well, how many decimal digits do we have? Those are digits to the right of the decimal point, 1, 2. So I'm going to multiply the denominator by 10 to the second power. Because I want to make an equivalent complex fraction, I'm going to multiply the numerator by exactly the same thing, 10 to the second power. Okay, each digit is going to get 2 places bigger. So in the denominator, it's going to be easy. We already know that this is going to be 125 as a whole number. That 1 is going to be there, the 2 is there, and the 5 above the 1 with a decimal point. So we have 125. That's our denominator. And our numerator, each is just going to get 2 places bigger. So that 5 is going to go right here. 5. Then, are there any other digits to the right? No. So I'm going to annex zeros until I get to the decimal point. And what number is that? 50. Okay, so this is really 50 divided by 125. All right? So 50 is going to go inside the division table. It's always the numerator, whether it's bigger or smaller, that goes inside the division table. And then on the outside, we're going to put the denominator, which is 125, what we're dividing by. Okay, how many? Let me put my, I'm looking at my dividend, and I don't have a decimal point in there. Oh, but I remember from this page, it says if you don't see the decimal point in the number, you annex it to the right of all digits. So I'm going to annex a decimal point to the right of 50. And then I don't have any other digits here, so I'm going to annex a 0 to the right of the decimal point as I need. So if I need more, I'm just going to annex more zeros to the right of the decimal point. Now I'm going to put my little blanks in my quotient and copy my decimal point exactly above from where it is in the dividend in the quotient. And now I divide as normal. I'm reading this now as 500 divided by 125, okay? All right. How many 125s are there in 5? 0. How many 125s are there in 50? 0. How many 125s are there in 500? Let me take a guess and say 4 of them. Let me do my multiplication off to the side. If this is too high, then I know I can go lower than 4. If it's too low, then I know I can go higher than 4. 4 times 5 is 20. Write the 0 down below. Write the 2 on top. 4 times 5 is 8, plus the 2 on top is 10. Write the 0 down below and the 1 on top. 4 times 1 is 4, plus the 1 on top, 5. Oh, I got exactly 500. So how many 125s are there in 500? 4. 4 times 125 is 500. 500 minus 500 is 0. Did I end up with a remainder of 0 to the right of the decimal point? Yes. Any other digits to pull down? No. So I'm all set. The answer is 4/10 or 0.4. Okay? All right, and then this last one, I am going to just write down, and I will talk about it after I go through the work. Okay, so I'm dividing. I'm not dividing by a whole number, so I multiply the denominator by a power of 10 to make it a whole number. What power of 10? Well, how many decimal digits do I have? 1, 2, 3. So I multiply it by 10 to the third. I'll also multiply the numerator by 10 to the third as well. Then I have an equivalent complex fraction to this complex fraction, which is 3 7/10 all over 5. So now I'm going to divide 3 7/10 by 5. And I'll copy the decimal point where it is in the blanks above. Just in case, I'm going to annex a 0. If I have to annex more zeros, I'll annex more of them. All right, here we go. How many 5s are there in 3? 0. How many 5s are there in 37? 7. 7 times 5 is 35. 37 minus 35 is 2. Is that remainder less than 5? Yes. It gives us permission to pull down the next digit, which is 0, making this 20. How many 5s are there in 20? 4. 4 times 5 is 20. And 20 minus 20 is 0. Did I end up with a remainder of 0 when I moved to the right of the decimal point? Yes. So I am done. The reason why I had to keep on going was because when I stopped right here, let me just highlight it for you so you can see. When I stopped right here, I ended up with a remainder that wasn't 0 to the right of the decimal point. If ever that happens, you just keep on annexing zeros to the right until you get a remainder of 0, or until you start to see a repeating pattern happen. But in 6th grade, we're just going to stop when we get a 0. Okay, so the quotient is 74 hundredths. Okay, and that is how we divide decimals. So dividing decimals, you first check and see, just as a summary, you check to see if you're dividing by a whole number. If you are, great, divide as normal. And if you're not dividing by a whole number, make it a whole number by multiplying the denominator or the divisor by the power of 10 that's necessary to make it a whole number. Multiply the numerator by the exact same thing. Then you'll get an equivalent complex fraction, which is simply the division of two numbers, 12.5 divided by 5, 12 5/10 divided by 5. And then you divide as normal. Make sure that you put your decimal point above in the quotient, exactly where it is in the dividend. And then you put your blanks to help you out. In the case of not wanting to miss out on any zeros, you're going to want to put your blanks. Okay? Then, as you're dividing, if you end up with a remainder that is not a 0, then you're going to just annex zeros to the right of the decimal point until you do get a remainder of 0. And lastly, one final thing to think about. If you don't see the decimal point in your number, it is always to the right of all of that number. So it's to the right of all the digits. You can put it right in, and you can annex zeros to the right as long as you want to, okay? So mathematicians, I hope that you now understand how to divide decimals. If you need to go back, please watch this video again, or pause it at certain points where you feel like you need to spend a little bit of time looking at what's going on or reviewing what was just said. I wish you all the best with dividing decimals, and I look forward to seeing you back